Last week I uploaded a video where we did a full disassembly of this PS1 2168. This looker had been dropped and we had to do a repair of the power supply. Inside the IBM we found a period correct kit, consisting of a Sound Blaster CT1740 and a matching Creative branded Matsushita CD-ROM drive. We fixed the bent pin on a 486 ODP R100 and tried it out on the board. Unfortunately, the BIOS couldn't support a level 1 cache and disabled all cache on the board. If you want to pause this video and watch part 1 first, you can find the link in the comment section below. In this video we are going to re-enable the cache, hack the motherboard to take a regular DX, and solder some more VRAM directly to the board. We are also going to do a factory restore with the bundled MS-DOS and Windows. And finally, we are going to try this PS1 out with a period correct DOS game. Okay, let's start with a couple of quick tests. So we have something to compare with. I have removed the ODP from the motherboard, so we are now running the SX. And as you can see, I have done the factory restore of camera to save some time. But if you're playing along here, you can easily find a set of disks online. Just search for IBM PS1 restore disks. These diskettes are for the desktop version of this machine, but they have identical motherboards, so I just reused these from another project. So if we start by taking a look at the resolution, we can only go to 256 colors, since we only have half a meg of VRAM, and a resolution of 800 by 600. And if you're playing along here, you have to jump into the BIOS settings and change the display settings from VGA to SVGA. Otherwise you're stuck at 640 by 480. We are of course going to improve this in a minute. Now this resolution is more than sufficient to play some good old DOS games. However, if you want to play around in Windows, let me show you what the graphics look like in this resolution. So I found this diskette from when I was a teenager and using this version of Windows on my daily driver. And as you can see, Claudia doesn't look too good in this resolution. We'll make a comparison after we have done some upgrades. Now let's jump over to DOS and run some benchmarks. And by the way, I got a very pleasant surprise when I did the factory restore. These diskettes also installed the Sound Blaster and the CD-ROM in DOS and in Windows. So that's a very nice time saver. And I find it kind of interesting because this also implies that perhaps IBM were selling these machines with this kit pre-installed. Why else would they include the drivers in the restore diskettes? And by the way, this is DOS 6 and Windows 3.1. So this system is obviously too slow for Doom as it is. But we'll see if we can change this. Well, it starts off reasonably okay. But now it's lagging like crazy. Let me crank up that brightness so you guys can see too. Yeah, that is way too slow. Not really playable. And these machines were sold with 4 megs of RAM. But I have 8 megs on the board now, because Doom wouldn't run with just 4. Well, pretty slow and sluggish. But I think without those local bus graphics, it would have been even worse. Okay, and we've got 7,113 real ticks. Now let's start upgrading. And I'm gonna start with the cache, for reasons that are going to be apparent in a minute. And if you're playing along, you will need 9 of these buggers for a full set. And I got this set off eBay, so these are untested. And to activate the cache, we also need to move these 2 jumpers. And time for the next test. Okay, let's see if this works. And unfortunately the refresh rate doesn't play well with my camera. So the flickering you see on the screen is created by the camera. Okay, well this is looking really good. So we've got 8K of internal cache on the SX25. And then we've got additional 256K level 2 cache. So all looking good so far. And down here we can see that our local bus graphics only has 512K. So that is our next step. Let's get that board on the bench and add some more VRAM directly to the motherboard. Okay, so in part 1 we tried to add some more VRAM to the zip socket here. Unfortunately it didn't work, so I probably have the wrong modules for this board. And that's a bit of a bummer, because I wanted to know if we could push this board beyond 1 meg of VRAM. And this board also has these unused pads sitting next to this VRAM chip here. So I got an extra chip and we're gonna add it to these pads. I'll move in closer so you can see. We already have some old solder on these pads from factory. So let's start by removing it. That way the chip will sit nice and flush on the board. That's much better. Now let's solder that chip. And since we have plastic parts very nearby, I'm not going to use the rework station, because I don't want to spend the time masking that thing off. I guess I better check the alignment off camera. Well, not the easiest thing to get on camera, but this is going pretty well. And I'm not sure if I mentioned it in part 1, but this board has local bus graphics. So that means the onboard graphics are way faster than any ISA card we could add to the board. And I'm going to use this IBM for early CD-ROM adventure games. Perhaps that's a bit of a waste, because this board has a lot better graphics than I really need. Okay, let me clean this mess up and check all the solder joints before we try the board out. Well, the DOF is so shallow at this distance from the board. I have to choose which part of the leg that gets in focus. I'll see if I can take a still and add in here. That shows the result better than this. Now let's clean this mess up so we can do a proper inspection. Okay, that should be enough for an inspection, and I'll do some more cleaning off camera. Well, this is the best I can do with the camera and lens I have. But that looks pretty damn good to me. So I'll do the rest of the cleaning off camera. And then we can move on and disable that SX25 with the bodge. I think I was slightly unclear on something in part 1. The 487 that this socket is made for does have an extra pin and will disable the onboard SX25. But it's not actually that extra pin that does the job. It's actually this pin here. I will put some kind of picture on the screen here that shows you which pin it is, in case you're playing along here. And it needs to be connected to VSS on this pin here. So you could actually just use a very short bodge wire between these two pins. But I prefer to make my bodges visible. So I'm gonna have these two wires coming up on the other side of the board. And if anyone tinkers with this board in the future, they will clearly see that someone has messed with this board. And I'm gonna secure these wires in case they ever come off. That's a bit too much. Okay, so now the wires are coming up here, but we're not going to short them quite yet. Let's first try out that VRAM and see if it works. Well, it posts and it boots. So that's a good start. And by the way, that included antivirus program. Actually found a virus on one of my original floppies from 1997. So I'm not going to turn it off anytime soon. Okay, let's jump into the settings and see if there is any change. And there is. We now have 1024 by 768. And we've got 65K colors to choose from. So that's a pretty huge improvement. But we can't combine 1024 with 65K colors. So I'm gonna go with 800 by 600 and 65K colors. And that's the perfect resolution for the original PS1 display. Well, it's too bad with all that flickering. But I'm still trying to figure this out. Now let's see what Claudia looks like with 1 meg of VRAM. And yeah, that is much better. That is a huge improvement. So that is a very useful hack for sure, if you have one of these boards. And I think I have seen those pads in similar machines as well. So you may want to check your board to see if you have any empty pads. Okay, let's disable that SX25 and see if we can get more speed out of this machine. And by the way, if you like this type of content, let me know with a thumbs up. Well, that should do the trick and be clearly visible for any future hackers. And I just noticed that this board doesn't have an arrow for where the notched corner should be. However, if we have a look at that ODP, that extra pin is in the same corner as the notch. So that means this corner here should be where the notch is. And we're going to start our tests with something cheap. So this is DX250. I checked in the manual to see how we should set these jumpers. And the manual obviously doesn't tell how to set them with a hacked board. So these are now set for use with a 487 in our socket here. And I think that's how I did it last time. Okay, fingers crossed. And by the way, the manual doesn't mention what those jumpers do. So they are a bit of a mystery. Well, it posts and it seems to boot, so that's a good start. Let's jump into the BIOS and have a look. And check this out, 486DX2, Mathco yes. And the video memory is now 1 meg. So we're doing pretty well here. But the tricky bits are yet to come. But this is probably where most people will be pretty happy with what they've got. This board will now happily play whatever adventure DOS game you want to play. But let's not stop here, let's continue. Okay, so these boards are 5 volts only. So we can't just add a DX4. Although there is a hack for it and I have ordered all the parts. So use the bell icon below and set it to all, if you want to get a notification on when that video is done and uploaded. But for now we are going to use an ODP R100. And this is basically a DX4 100 that runs off 5 volts. Let's give it a try. So let's boot. Now we get a 129 cache error. So if you have seen part 1, you know that we have this problem. So basically the BIOS has some trouble with the internal cache and completely disables it. And for some bloody reason it also disables the external cache. So this system is basically in limp mode now and extremely slow. Way slower than with the 25SX. So let's replace that BIOS with Tom's hacked BIOS. I haven't done one of these boards in about a year or so, so I don't remember all the details. That's why I put the original BIOS back on, because I wanted to see exactly how it behaves. Now let's try with this hacked BIOS here, and we will see exactly what it does. Let's boot and see. And no error. Let's jump into the BIOS and have a look. And as you can see, the internal cache has been crippled because the ODP R has 16K, but we only get 8K. And the external cache is back. So what that BIOS does is to prevent the system from disabling the cache. But this board doesn't seem to be able to handle 16K of cache. But still, this is a huge improvement from when we started. So let's do some benchmarks. Let's try SpeedSys and see if we really have some working cache on board. And it drops at 16 and then at 256. So either I'm mistaken or This looks like it's actually using all 16K and a 256 on board. Although I haven't messed around much with this, so please comment below if I'm correct here. But from what I can see here, the curve drops at 16K and then again at 256. So that tells me we have fully working cache on board. But this is a bit weird, because in my previous project with one of these boards, I ran Doom on a DX475 and did a comparison to the ODP R100, and I think I got the same result. So something is fishy and I don't know what it is. So let me know your thoughts down below. And now it's time for the fun part. Let's run Doom and see what kind of speed increase we got with all these hacks and bodges. Okay, here goes. Well, that is a huge difference. I don't know at what FPS Doom's max out, but this is really quick. And we've got 2886 real ticks, so that gives us 25.88 FPS. That's a pretty fast PS1.
I think your PC is slow.
Oh, shut up, Mac. Well, restored parts are piling up on the bench. I think it's time for a reassembly. Okay, time for a test. And I decided to add some more RAM. Well, it still seems to be working fine. Oh no, that sounded horrible. Something is wrong with the sound. Let's give Canyon Mid a try. Oh, that sounds good. How weird. Let me move the microphone. Yeah, so as you can hear, there's nothing wrong with the sound when we play this track in Media Player. So that problem only seems to be affecting the Windows boot sound. How bizarre. Let's try a game. And for some bloody reason my CD-ROM drive is E: instead of D. That's a bit annoying. Okay, let's choose sound card. Okay, and we've got a memory error. So let's see if we can fix this. Let's jump into config sys. And try to remove this line here. Okay, let's try again. Okay, and this time it worked. Let's choose custom. And nothing happens when I press C. Let's try express. Nothing, so the damn thing hanged. And the entire system just hanged. Yeah, something fishy is going on here. Let's try with another game. And the PC speaker works too. Well, that's weird. This is working perfectly. I'll move the microphone. Take a listen to this. So the sound works in this game and with the media player. How strange. Okay, let's try to boot. And we've got a hanging note. So let's try that again. Well, this is weird. I tried again and now it works. But I think I may have found the problem. IRQ and DMA are grayed out and they are set to 5. And that is not how my card is configured. So let's change the jumpers on the sound card. Well, luckily I installed the sound card at the very bottom of the case. And since we don't have any cards on top of it, I can just change the jumpers without taking the card out. So let's change the IRQ to 5 as suggested in the game and see if that works. Okay, let's try again. Well, that PC speaker sure works, and luckily we have a volume knob, which is rather unusual. No, that still sounds like crap. Let's jump into Sound Blaster config and have a look. Well, it's set to 5 here, and DMA is set to 1. Well, I'm not sure what to make of this. It's a rather strange fault. Let's try with another card. That might point us in a direction. Okay, I found another Sound Blaster 16. Let's try with this card. This one is 2770 and it has the correct pin headers for our odd CD-ROM. So let's see how this behaves. And that sounded good. Huh. So do we have a faulty card? But why did it sound good when we used the media player and one of the games? How bizarre. Let's try the dig. And these CD-ROMs may be very slow, but they are also very quiet. And a double speed drive is actually the minimum requirement for this game to even play. And it still hangs in the configuration utility. What on earth could be causing this? I went into the settings and I got this error. Error found in MIDI port settings. I can't really see how this could cause our problem, but let's fix it anyways. So, and by the way, I have switched back to the original card. And it's set to 330. And I checked the rest of the values and they are correct. Okay, and now we've got a configuration error. So let's see if this will give us a clue. CD-ROM drive not installed. Oh, that's weird, because it is installed. And I can't see anything in here that uses the address. So I guess we'll have to change it on the card instead. Let's give that a try. Well, I changed the address on the card and of course we got an error in Windows. But that was of course expected. So let's change to 300 and see if this makes any difference. Okay, let's boot and see if it made any difference. And the CD-ROM error went away. That's strange, we still got the error. Well, it hasn't changed. That's weird. So let's try again. Why wasn't my settings saved? Well, I guess we should try again. And we still got an error. So for some bloody reason it doesn't accept my changes. That is weird. Okay, so I think we should reinstall that card. So I have disabled all the settings for the Sound Blaster in the AUTOEXEC batch file. Let's reinstall that card. And the installer suggests that we use all the default settings. Let's not change this. Now, these drivers are quite a bit newer than the ones we have installed. And by the way, these drivers corresponds well with when this machine was new. So again, this implies that IBM might have been selling these machines with this kit pre-installed. Okay, fingers crossed. And I have turned the brightness down all the way on the display, so it will be easier for you to see what I have on the screen. That's why some things look black. Ah, crap, we still have the same fault. Okay, well, updating the drivers made the game start. But we still have crackling noise. So it didn't fix the sound. Huh. Let's test that card in another machine. Well, video is getting lengthy, so I skipped some tests here. But I tried our card in the Commodore 486 and it kept crashing the entire system. So unfortunately I think this card is faulty. So I have replaced the card in a machine now. Let's see if we can make it run the dig. And it works. And sound is perfect. So unfortunately I think that Sound Blaster is bad. I guess I'll do some reading. And then I'll make a repair video.
Of course I miss you, darling.
Well, faulty card or not, I'd say this was a successful project. This IBM is now 2.5 times faster than when we started. I deliberately chose the dig to do this test, because it's several years newer than this machine. The system requirements vastly exceeds the specs this IBM had before we started the project.
We have exactly one chance. We've got to do it right. Let all your prayers be with us.
If you have any ideas on how we can make it even faster, please share your thoughts. If you want YouTube to notify you when the next video is out, you can use the bell icon below and set it to all. Now is a good time to watch part 1 if you haven't seen it yet, or catch up on one of my previous projects. I would like to end this video by saying thank you to my very first patrons. Your support means a lot to me. If you want to become an early supporter of this channel too, you can use the link below this video.